everybody, it's Mrs. Pound, and I'm back with more from Chapter 11 on chemical calculations from BJU Chemistry's 5th edition. The section we're going to talk about today, we're still in section 11.1, and this is the third video, video C, on empirical formula calculation. So remember, those empirical formulas are those simplest ratio formulas. So our objective for today is to calculate an empirical formula from the percent composition of a substance. So if we're going from percent composition to the empirical formula, these are the steps that you will follow. A question might be, an unknown compound contains 75% carbon and 25% hydrogen by mass. What is the empirical formula of the compound? So the first step is we will assume that you have a 100-gram sample. So the compound contains 75 grams of carbon and 25 grams of hydrogen. So for this step, we simply change the percentage to grams. Percentage becomes grams. Then you're going to determine the number of moles of each element. So let's start with the 75 grams of carbon. Remember, we do this using the molar mass that we get from our periodic table. So we look at our periodic table and we have carbon. So right here, the molar mass is 12.011. I'm just going to use 12.01 because of the 4 significant figures there. So 12.01 grams of carbon goes on the bottom, so it can cancel. We put our 1 mole on the top, and when we divide, we get 6.245 moles of carbon. So we're still at the second step, but we also have to determine the number of moles of hydrogen. So we have 25 grams of hydrogen. Again, we look at our periodic table. Right here is our molar mass, 1.00794. So I'm going to round it off to 1.008 grams of hydrogen. That goes on the bottom, so it cancels, and 1 mole goes on the top. When we do the division, we get 24.80 moles of hydrogen. We have to pay attention to those 4 significant figures. Step 3 is to determine the mole ratio by dividing the number of moles calculated by the smallest number. So we had the numbers, we have the mole ratio, moles of carbon to moles of hydrogen. So we divide the carbon, 6.245 by 6.245, and the hydrogen, the 24.80 by 6.245 as well. So that smaller number was the carbon, so we divide everything by that smaller number. And we end up with a ratio of 1 to 3.97, which is really close to 4, so we just round that number off to 4. So it's a ratio of 1 to 4. Now we have our empirical formula. There's 1 carbon, 4 hydrogens, but remember we don't write the 1, so it just becomes CH4. So that is how we define the empirical formula. Now there are variations on this problem, so let's take a look at a variation. We want to go from the mass composition to the empirical formula. So an example of this type of problem is a 5-gram sample of an unknown compound contains 1.844 grams of nitrogen and 3.156 grams of oxygen. Find the empirical formula. So for this problem, we actually start at step number 2 from the previous problem. So this is a little simpler. We find the number of moles of each of the elements. So for nitrogen, we have 1.844 grams of nitrogen. If we look that up on our periodic table, there are 14.01 grams of nitrogen in a mole. So those cancel, and we end up with 0.1316 moles of nitrogen. For the oxygen, if we have 3.156 grams of oxygen, we look at our periodic table and there are 16 grams of oxygen in 1 mole, so we get 0.1973 moles of oxygen. Now we figure out that mole ratio, and so our moles of nitrogen to our moles of oxygen, our smaller number is that 0.1316 for the nitrogen, so we divide both numbers by that. So the nitrogen here, the 0.1316, and the oxygen, the 0.1973, and we end up with a mole ratio of 1 to about 1.5. And we know that we cannot have a subscript of 1.5. So if the ratio is not close to a whole number, express the numbers as fractions and multiply by the common denominator. So 1 to 1/2 can be expressed as 2 over 2 and 3 over 2, because 3/2 is 1.5. So when we do that, we then multiply by the 2, and we get a ratio of 2 to 3. You might have also realized that you could just multiply these numbers by 2 from the beginning because of the 1.5. So our empirical formula is N2O3. Now, one last variation is going from percent composition to the molecular formula. We just need one more piece of information to do that. So an example is caffeine is 5.170% hydrogen, 16.49% oxygen, 28.86% nitrogen, and 49.48% carbon by mass. The molar mass of caffeine is 194.20 grams per mole. Find its molecular formula. So for this problem, we actually start at step number 1 from the first problem. So we take our percentages and we just turn those into grams, and then we find the number of moles. So we have 5.170 grams of hydrogen. We convert using the molar mass to moles. So the molar mass of hydrogen is 1.008 grams, and we get 5.129 moles of hydrogen. We do the same for oxygen. There's 16.49 grams of oxygen. We divide by the molar mass, 16.00, do that conversion, and we get 1.031 moles of oxygen. We then do that for nitrogen. Nitrogen, 28.86 grams of nitrogen. We divide by 14.01 grams of nitrogen in 1 mole, and we get 2.060 moles of nitrogen. And finally, we have carbon, 49.48 grams of carbon. We end up dividing by 12.01 grams, the molar mass, and we get 4.120 moles of carbon. So now we find those ratios, and the smallest number was 1.031 from the oxygen. So we divide the number of moles of each element that we found by the 1.031. So hydrogen is 5.129 divided by 1.031, and we get 4.974, which is really close to 5. Oxygen divided by the oxygen, the 1.031 divided by 1.031 is 1. Nitrogen, 2.060 divided by 1.031 is 1.998, which is really close to 2. And for carbon, 4.120 divided by 1.031 is 3.996, which is really close to 4. So our empirical formula is C4H5N2O. But we want our molecular formula. So to do that, we need to find the molar mass of C4H5N2O. So we just take the carbon, which we have 4 atoms of that, multiply by the molar mass of carbon to find that mass. We then take the 5 hydrogen, multiply by the molar mass of hydrogen to get the total mass of those. And then the nitrogen, to find the mass of the nitrogens, 2 times the molar mass of nitrogen, we get 28.02. And then finally oxygen, 1 of those times the molar mass of oxygen, we get 16. So we add those up, and now we have our molar mass of the empirical formula. Finally, we're going to divide the molar mass of caffeine by the molar mass of its empirical formula to get a ratio. So this is the molar mass of caffeine, and it's 194.20 grams per mole. The empirical formula molar mass is 97.10 grams per mole. When we do the division, we get 2. So we take that number and we multiply the subscripts of the empirical formula by the ratio to get the molecular formula. So here I put the 2 outside here so that we would know we multiply through, and we get C8H10N4O2 for that molecular formula. So our objectives were to calculate an empirical formula from the percent composition of a substance. Don't forget your 5 questions in your notes, and we will be continuing with stoichiometry next.